Good evening, techies. I am Rima from the social media team of Cloud Native Hooghly. Welcome aboard to week 5 of Kate Smashes. Today's session will be about introduction to Docker. कितने लोगों ने Docker का नाम पहले सुना था या यूज किया है? Write in the chat. Okay, someone raised hand. And others? Okay. There are a lot of participants right now. Everyone, please respond. Okay. तो मैंने तो नहीं सुना था पहले बट थैंक्स टू केट स्मैशर्स इस टॉपिक को बूट कैम्प में इंक्लूड करने के लिए. It's safe to expect that we will be discovering the fundamentals of Docker, its practical applications, and learn how it empowers developers. और केट स्मैशर्स रियलिटी और एक्सपेक्टेशन हमेशा मैच करवाता है, unlike our lives. So let's clear the fog now, and without any more delay, I would like to introduce the esteemed speaker of this session, Harsh Mishra, who is an engineer at Local Stack with the wealth of knowledge and experience in the field of containerization. Our speaker is truly a captain of the Docker seas. Now, I would like to focus the spotlight on our speaker. The mic is all yours.
Hello, thank you. I hope I'm audible to everyone out here. Can I just get a quick yes if I'm audible to all of you?
Yes, you are audible.
Awesome then. Thanks a lot, Rima, and thanks a lot, Cloud Native Hooghly, for having me for this session. And I guess without much ado, I guess I can just start sharing my slides and maybe get started really quick. So I need to find my slides because there are so many tabs open. I hope the slides are visible to you. Can I just get a quick yes, maybe? Okay, awesome then. For folks who don't know about this feature with Google Meet, there is this nice way to basically react through emojis. So if I'm basically asking any questions, it would be great if all of you can just drop a thumbs up or something like that, so that I can get a quick validation that everything is running smooth. Awesome then. I guess we are a pretty small crowd, but I think giving a talk with a small crowd is always the best because the reactions are really quick and people learn quite a lot. And with that said, I want everyone to treat this just as a fun way of learning Docker. I'm pretty sure that most of the things, most of the technical jargons will simply fly over your head. And there is no way of getting all that knowledge, all that experience that I had for the past 4 years. I'm still learning about Docker. There is still something that I learn about it. So absorbing all of that in just an hour or maybe 2 hour long session is not enough. So what I would definitely like to suggest is please start maybe a note or maybe open your Google Docs or something else, and maybe start taking up all the links or maybe all the technical jargons that I will be sharing. The best thing that you can do, and this is something that I used to do in my own time in college, so you can basically take a list of all of them, and once the session is over, you can start going over the internet, you can start searching for them, finding out what's the right information, and then coming back and try to reiterate on your own knowledge and your own understanding and try to improvise that a bit. I guess this is a very great learning tactic that I personally use, and this is going to be super helpful for you as well. Awesome then. And I guess this was pretty much what I wanted to say before we start. So hi, I'm Harsh. I'm presently living in Darjeeling, by the way, and I guess most of you are from West Bengal, which is kind of good. Um, I have been working with a company called as Local Stack for the past 2 years by now. For people who are not familiar with what Local Stack is, then it's an open source tool that allows you to emulate your AWS services. And the fun fact is that the Local Stack is pretty much based on the Docker itself. So I get to work with Docker almost on a day-to-day basis. I have been working with Docker for the past 4 years, and my experience has been topsy-turvy, like across many different companies. So some of the companies that I use Docker at include Red Hat, HackerRank, QXF2, and even my own present company where I have been like dealing with some of these stuff altogether. So again, I'm not pretty much like an expert at Docker or something like that. I just happen to know a few things, and rest of the things, I guess I can try to share that with you. Maybe go over the documentation, go over some of the online articles, and try to fill in the gap that is present in my own knowledge. So if I'm overstepping or if I'm misstepping, please pardon me and let me know if I'm just going way too fast or if I'm speaking way too many technical jargons that you're not able to understand. So feel free to interject me, put something on the chat, and I would definitely get to take a look at it at specific intervals. So yes, this session is all about introduction to Docker, and in this session we have some good plan about covering at least the basic concepts. So in this session, I want to discuss a few things about like how Docker exactly came to be, because a lot of people talk about Docker, they talk about the tool, they talk about the project, but very rarely I believe like people talk about the actual story behind Docker, like why do they exactly need Docker and how did such a tool like Docker exactly came to be. Because you will be surprised to know that Docker is a very simplistic technology. It's like the whole concept is really really simple, and you can kind of build your own Docker maybe in just less than 1,000 lines of code or something. So this was something that was pretty much an obvious concept, but it simply took over when Docker started. And it has become such a ubiquitous tool right now for containerizing your application. If you don't know what containerizing your application means, do not worry, we will be going through that. So we are going to be covering like a short story. We are going to discuss like what was the motivation behind Docker. We will see some other technologies that are in the same space. That is pretty much like an antithesis of the container-based philosophy. And this is where we will discuss about virtual machines, about Vagrant, and all of these. Then we will cover about what is Docker, what are containers, what are images, all of the technical jargon that you might be fearing right now, but do not fear it. I guess I will be covering over that in as easy way as possible. But again, if you are not able to understand something, just let me know about it. And again, this session is not about just talk, 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 talk. It's also going to be a bit hands on, and we will be going over 3 or 4 samples that I have prepared. These are very, very lazy samples, may work, may not work. I hope the demo gods are with me. And finally, we will be covering a bit about Dockerfile, life without Dockerfile, life with Dockerfile, and we'll also cover like how you can write your own Dockerfile. You might notice that I'm missing out a few other things that you might know about, like Docker Compose is not there, Docker networking is not there. But again, as time permit, I will definitely try to cover that. But again, we have to make sure that everything is encapsulated in maybe an hour and 30-minute long session. So let's get started. But before I start, I also want to know about all of you. Like there are more than 40 people in this session. So again, like most of you might have widely different experiences, different exposure to different technologies. So for that particular scenario, I have this one simple Slido session prepared. So all I want is just open a new tab on your browser or maybe your smartphone, go to slido.com, maybe just enter this particular code over here, or even better, maybe just scan this QR code and basically join the Slido session. I have just 2 simple questions that I really want to ask. The third question I'm going to ask at the end of the session, and this will basically get me a definite idea of what kind of an audience I'm dealing with. So again, not very complex. I guess this is going to take like 30 to 40 seconds here and there. So I'm sharing the link on the chat so that it's very much easy for all of you to join it. So yeah, you can just go over to slido.com, maybe just enter this code, or else you can just click on the link that I have shared on the Meet chat. And I hope everyone is joining this session on your laptop or your desktop, whatever you prefer. So can I get a quick thumbs up from everyone who has joined, or anyone who has not joined? Can you please put that on the chat? Okay, I guess I am pretty assuming that everyone has joined. If you have not joined yet, or if you're facing some issues, just put the answers to the questions on the chat itself. So here we go. What year of study are you in now? This question is very important for me to understand, like what kind of like language should I be using and things like that, so that I just don't speak way too many technical jargons. Awesome. Then I guess most of you are in your second year of studies. If people have some free hands, can you also mention like which college are you joining from? And is everyone joining from some particular college in West Bengal, or you're joining from some other states? I guess I would definitely like to know about that as well. I guess we have a pretty good mix for second years, third years, and first years. I guess final years are not well represented yet, but I guess that's pretty much okay. The second question that I wanted to ask, this is like a multiple choice, so you can basically select like more than one options over here. I hope so. So which of the following concepts are you familiar with? Because I have been seeing like this is a part of a whole boot camp because you have been like learning different things over multiple weeks. So I'm pretty assuming that you must be knowing about a few of the things over here. I saw like you had a few sessions on nitty, maybe networking. I guess you are going to have a session on Kubernetes the next week or so. So I guess it is pretty good represented. Yeah. Awesome. Then I guess most of you know about virtual machines, so I don't have to stress too much on that concept then. Awesome. Thank you so much for participating in this Slido. And with that said, I guess we can just jump right into the session. But just one point, if you have any questions, please feel free to put that on the Slido itself, or else please put that on the Google Meet chat. I can pick up questions from either of the places. Cool. So let's get started. Let's maybe start off with a short story that almost every systems engineer likes to tell before talking about any of the DevOps concepts. And this story is pretty old. It basically starts off with the classic client server architecture. So back in the old days, when people used to build software, they have to basically expose the software to some of the users, maybe their clients, maybe some general group of people or something like that. So in that case, what people used to do is that they used to have like a server and they used to like have a client. And there was like a direct one-to-one relation between the server and the client. So this server basically used to run your application, and the client was basically a mechanism for the users to use your application. It was very, very simple. It was very, very ideal. There was no problem at all until and unless people really started to think about scaling issues. So, with scaling issues, the answer was pretty obvious. You can either vertically scale or else you can horizontally scale. Back in the days, what people used to do is that if tier system was hitting a particular scale where one system or one server was not able to accommodate that many users, the best thing that people could do is like maybe just rent more computers or rent maybe more servers. So if we have like two applications, we needed two servers, or else if we had just one application and we needed to serve to like a globally distributed user base, we just like had multiple servers serving the same kind of an application. So it was that simple itself. Like everything was really, really ideal back in the old days. But this is where people started hitting the limitations. More applications means more servers. And like even within a single application, you have to like create multiple servers so that you can basically scale, you can distribute the traffic across multiple servers and so on with that. The additional problem here was not just with provisioning and managing servers, it was also about some of the other additional things that the developers did not wanted to care about. The first and the foremost thing was about the networking. I guess DNS failovers, setting up proper configuration, things like that were really, really tedious and really, really complex. This is where the whole like job titles like system administrator, system engineer, system architects, like these kind of job roles basically came about because the entire concept was about managing these servers so that they can perform really, really well. The second idea was, of course, the backup. If you are running an application, of course, you must be having some sort of a database running with it. So, what happens if your server goes down? If your database is hosted on the same server itself, even that goes down, and that's gonna create like a lot of troubles. So, you had like backup configurations, you have to like run these manual or automated backups every now and then. And again, that part was simply tedious. Apart from this, there was operating system installation and configuration. Not just that, you had to basically maintain this operating system, you have to maintain these versions. And every time there was a version upgrade due to a critical security vulnerability, that was quite a mess. And this used to create like a bit of a downtime because now your application needs to be spin down, your operating system needs to be patched up, and then your application needs to be restarted so that it can start serving its whole user base. All of this was very, very tedious, it was very, very complex, and it was very, very time consuming. So the obvious answer to this particular question was virtualization. I guess most of you already mentioned that you know about virtual machines, but I'm just going to take like a couple of minutes just to go over the basic concept once again, because it is very, very crucial for us to understand virtualization before we understand a bit about containerization. So virtualization was a very simple concept. It meant that now your operating system can act as an emulator for multiple other systems. So a virtual machine is nothing but just an emulator of a physical computing environment. So it used to emulate as if it was some other computer. And on this computer, you can install your own operating system, you can install your own bit of software, you can also host your own application on top of that virtual machine. So the entire idea behind virtual machine was that we have this one system of ours, and we will divide the system resources like the RAM, the CPU, all of the things, so that it can be shared between multiple different applications. So this idea was pretty radical. I guess it came about in 1980s or 1990s. And with this idea, we had basically these virtual machines, which was the perfect uh, solution for our demand of just having one system where we can spin up like multiple different applications. So as it happened, the whole idea of that we have this one server and there was this one application hosted on it was simply like an age-old idea. Now we can have one server, and over that one server, we can have multiple different applications hosted on it. This was the idea that basically led to AWS, GCP, Azure becoming so popular, because what they started doing right now is that they started using this whole virtualization technology to kind of start giving the companies a way to rent servers, and these servers are nothing but just physical machines. And these physical machines have this virtualization layer that allows them to run multiple different applications on the same server. So if you're basically creating a virtual machine on AWS right now, it does not mean that you're renting your own machine or you're basically renting some sort of like a hardware rack or something like that. It basically means that you're just taking up a space on another rented machine that is already hosting so many applications, and you're basically finding a way where you can tell your application that, hey, what you're running on is just another system and you should not basically care about any of the underlying details. This is what virtualization basically enabled people to do. And it was such a massive factor because without virtualization, without these virtual machines mimicking or basically emulating basically bare metal systems, we could not hit the scale with what we are doing with AI or LLM or GPTs right now. Basically, virtual machines was the reason why cloud computing became so popular and became so affordable. And with this, we solved like plenty of troubles. We solved the trouble with the networking, with the backups, because now atop these whole virtual machines, cloud providers can build their own managed services. Like AWS built over 200 plus services that solves a lot of business problems. You want to create virtual machines? Hey, you have EC2. You want to create databases? Hey, you have RDS, you have DynamoDB. Hey, you want to create serverless functions? You have Lambdas, you have more of the other tools. So with these managed services, companies started finding like a lot of ways to solve their most pertinent business problems. But the most obvious difference was the cost factor. Because of this cost factor, companies can hire more engineers, they can scale up their systems, and they can really hit a massive user base that would have otherwise been not so much possible. But there were obvious troubles with having this virtualization layer. The problem was that virtual machines used to waste a lot of resources. Now, as I mentioned before, virtual machines basically take a share of the system that they are basically running on. And this basically means that every time you create a virtual machine, you are giving it a share of your CPU, your memory, your hard disk, your network, your other hardware resources. That would simply make it very, very tedious for you to run like multiple virtual machines on your same system. How many of you have like actually created a virtual machine on your laptop? Can I just get a quick raise of hand? Yes, I guess some of you. And I hope most of you also face a trouble that I am speaking about right now. Like every time, like I remember, like I used to have this age-old Windows operating system atop like an Intel i5 machine. And every time I used to create a virtual machine, it just used to be so much slow. And this basically was a very, very bad experience for me. And I guess most of you can kind of agree to it. Um, so this was the traditional problem with virtual machine. And of course, with the virtual machine, you obviously like, especially the cloud providers, they have to think about a lot of other factors. They have to think about how many applications or how many virtual machines can they run on a single server or on a single system, and more of such problems that basically started coming about. And as I mentioned, the reason why virtual machines were popular was because of this whole hypervisor layer. So this hypervisor layer basically allowed your operating system running on your specific hardware to kind of mimic this entire concept of an additional operating system on which an application can basically run. So this hypervisor was the particular layer that basically enabled the whole virtualization technology that enabled you to create virtual machines. And on top of these virtual machines, you can basically install multiple operating systems. So that was a basic technology, but again, it had its own specific troubles. Now, to solve some of these issues, there was not like this tool is still very much popular, it still very much exists, and this is called as Vagrant. Has anyone heard about Vagrant yet? Just curious. I guess no. So let's see. I guess some of you have, or some then. So Vagrant was like a very popular tool. I guess like it has ran into some specific licensing issues, but it still is very much popular. And the whole idea behind Vagrant was about giving you a way to define, manage, and create virtual machines on the fly. So with Vagrant, you can basically create like multiple virtual machines using just one single Vagrant file on your code repository. And this was very, very effective for you to like basically manage a bunch of virtual machines. So a lot of the traditional management troubles that virtual machines came to be, Vagrant was pretty much solving this out of the flow. But again, it did not solve like some specific troubles. The obvious trouble was about the basic inherent limitations with like the virtual machine technology itself. Now, Vagrant was very much perfect for creating virtual machines. It had this whole repository with pre-defined virtual machines that you can install, you can download, and you can run it on your machine. But again, at the end, it was just running a virtual machine. So with the virtual machine, the cloud computing basically got a new boost. It got like a new life, but it still was facing a lot of traditional troubles. The troubles with like sharing the resources across multiple different virtual machines, managing them, upgrading them, things like that, that simply needed a way to basically come out. Like people wanted to find a solution to that. Now, this is where our short story ends. This is where we basically enter into the realm of Docker. So, Docker is now a very popular tool, technology, or whatever you call it, but it's a piece of software that basically allows you to create containers. And what I mean by containers is that you can basically package your application, your runtime, and whatever dependencies or whatever tools you need into one single environment that is isolated on your host machine. This is the essential aspect of Docker. And basically, what Docker does is like it packages everything inside this one sandbox. And this sandbox is basically called as a container. So if you're confused, like, okay, what exactly is Docker? What exactly is container? I guess a single line definition that I would like to share is that Docker is a tool that allows you to define images, and these images can be run as containers. That is it. One thing that you need to note is that container is not specific to Docker. Docker is an agnostic tool. It does not own or it does not like really has a control over the container technology. There are other competitors of Docker, like there is Containerred, there is Podman, there are some other tools or technologies that allows you to define and create containers. But Docker was one of the most popular and one of the first tools, not the first tool exactly, that basically revolutionized the concept behind containers. Now, if you actually take a look at how exactly Docker came to be, what I would really, really suggest for you is to go ahead and check out this one particular talk. I'm going to share this link with all of you so that you can look at it. But just remember that this 5 minute video where the speaker was almost interjected at the end that, hey, your time is up, maybe you should stop now. This 5 minute video was kind of responsible for the whole container technology to kind of shoot up. This talk was presented by Solomon Hykes, who was the CTO of Dot Cloud, if I remember correctly. And he was also the creator, like one of the first committers and the creators of the Docker tool itself. And he presented this talk at PyCon US 2013. PyCon is the flagship Python conference, and they have like these conferences happening in almost most major countries where there is a sizable Python community out there. So he presented this talk. Just have a look, and this will basically give you a lot of context about how Docker basically came out to be. But one interesting point that I wanted to share is that the concept behind Docker, and this is something that I said at the very start, you can write your own Docker maybe in just less than 1,000 lines of code. I can basically prove you that. I won't basically write that in front of you to be specific, but I can show you like how Docker was kind of created from existing tools or technologies itself. So one point is that Docker is not new. There have been tools, there have been technologies that were really, really similar to Docker and that were created ages ago. For example, I guess this talk was presented in 2013, so maybe this year can be the start for Docker. But a similar technology called as Jails, I'm not sure how many of you have heard about it, but this technology was very, very similar to Docker itself, and that was created almost back in 2000 itself. And the first version was maybe written in the last century. If you actually go deep down into this, you will know that one of the first innovators in the container space was actually Google. So Google wrote this one piece of technology called as LMCTFY, and it basically means like let me contain that for you. How many of you have heard about Kubernetes, for example? Can you just show a quick raise? I guess a lot of you. How many of you have heard about Borg? BORG? Anyone? I guess no. So Borg was a pretty interesting tool. It was basically the precursor for Kubernetes itself. So Google created this one technology called as Borg, and you can basically just call this as like the precursor to Kubernetes because what Google did is like they tried to revamp Borg and they just donated this to Cloud Native Computing Foundation, basically the CNCF, and CFCF rebranded this as Kubernetes itself. So Borg internally used containers. And for them to use containers, they were not relying on something like Docker because Docker did not even exist back then. So what they were relying on, they were relying on this particular tool. And it basically meant like, let me contain that for you. So container technologies or container tools are not like very, very new. They were not created by Docker itself. And the very basic concepts were created way, way back. And if I just go back to my slides, it was actually created when the Linux maintainers added this one particular feature called as namespaces. Yeah. Okay. So I won't go into the specifics of namespaces and all, but what namespaces basically allows you to do is that it allows you to create an isolated container that simply has no access to objects outside it. So basically using this, you can create like multiple executions, like multiple isolated executions within a single operating system kernel. And this was the basic start where people started to think like, hey, can I basically create a namespace? Can I give this like a unique file system or something like that? And can I run my applications inside it? And when people started thinking in that direction, this is when container technology started really shooting up. Now, when I said before that, hey, containers, like you can create your own Docker-like tool in just 1,000 lines of code or something like that. What I wanted to mention is this. This is a tool called as Bocker. It was basically created something like a proof of concept or something like that, but it has been implemented in less than 100 lines of shell script. So maybe I can share the link with you, and maybe some of you folks might find this interesting. But this basically shows you like how easy it is for you to create like a preliminary Docker-like tool. And this can be like a pretty fun experiment to like do and experiment with. Like I personally did that when I was in my own college. And if you want to like go neck deep into how like what are the Linux concepts that basically goes behind this entire idea behind Docker, there is this really interesting blog that I can share over here. But it basically tells you like how you can build your own Docker using things like namespaces, C groups, chroot, and more of that. But all that I wanted to do was bring up to the point that containerization is not new. It was a technology that was created way, way back. And what Docker did is like some pretty interesting and opinionated ideas that simply made it very much popular. So let us maybe talk about that. So yeah, what is Docker? I guess most of you have got a pretty strong definition. Now, the advantages of using something like Docker and the underlying container technology is really very simple. With your containers, you don't need to boot up the operating system. Like you do not need to like basically depend on the virtualization layer. You can basically create it on the fly. And the entire footprint, like the whole memory footprint, is very, very small in comparison to actual virtual machines. But the real aspect why containers became so much popular was because they were really, really easy to distribute. Like packaging them and distributing them was kind of like a child's play, not to just demotivate others. But this is exactly like what made Docker so popular. I guess I can throw in my own personal take and I can say like what made Docker so popular. I guess there were mainly three reasons for that. The very first reason, of course, was something that was called as Docker Hub. I guess most of you might have seen this screen if you're searching about Docker or if you were researching about it. But what Docker really invested on when it was starting up was creating this one library of like container images from all over the internet so that people can easily get started with creating their own Docker images and running their own Docker containers. Like Docker Hub right now is pretty ubiquitous if you are creating like your own Docker containers, because most of the dependencies are basically coming from this one single place. Like take for example something like maybe Node. Uh, if you actually search for Node, we have the whole Node Docker image over here. Don't fret out if you don't know what an image is. I guess I will definitely cover that up like later in the session. If you want to search for something like, let's say, Python, you will definitely get to see that we have an official Python image. So with something like this, Docker had a definite distribution advantage, because now anyone who wanted to get started with containers, they can simply use Docker and they can simply pull these images and basically start writing their own Docker files. Please don't fret out if you don't know what Dockerfile is. You will definitely get an idea of that like later in the session. The second reason why I think that Docker got so much popular is because of the OCI. I'm not sure like how many of you again like know about OCI, but what Docker did is like they established this whole open container initiative. Now, the underlying technologies behind creating like a container based technology was already there, like namespaces, C group, chroot, more of these things, even networking parts and all of that. What really made Docker so distinguished was this whole initiative that they started up. And this basically made sure that whatever container like technology that you use, either you use something like Docker or maybe Podman or Container Red, all of them should basically follow this one specific industry format. And this basically is now adopted by the Linux Foundation itself. And this enforces the idea that, hey, if you're creating another competitor to Docker or Podman, this is the runtime specification that you have to follow. And this is very, very important because this basically governs and this basically states like how you should be creating your containers. Without that, every other tool would be using some other specification or some other underlying like runtime or something like that, and it would be pretty much like a mess. Just imagine migrating your Docker setup to like a Podman setup. It would be like too much of a mess if all of them would not have kind of agreed to following this one particular runtime spec. This is what Docker basically nailed down, and this is what basically got almost the other tools also started like covering up on the whole container landscape. So according to me, these were like the three reasons why Docker became so much popular. Okay, I did not mention about the third reason, and that is obviously going to come up like later in the slides, is that Docker shipped out with a really great user experience. And this user experience was governed by the Docker command line interface. I guess since most of you already mentioned that you are familiar with things like Bash or Python or maybe something like that, I guess you might not be fearing too much of command line toolings itself, but we'll get on to that later. So as I mentioned before, Docker does not depend on hypervisor. It does not depend on virtualization at all. You have your hardware, you have your operating system, and on top of your operating system, you can spin up like multiple containers. You can spin up one, two, maybe 100, maybe 1,000. The maximum containers that I have ran at a single time was almost maybe 6 to 7,000 or something like that. This was like on a very supreme Mac M2 chip. So just so that all of you have like a bit of a context. But the point is that Docker is so lightweight and it's so much ubiquitous right now that it's very, very easy for you to start creating your containers. It's very easy to start shipping your containers. And on top of that, I guess you might have seen this through some memes that I saw on your Instagram channel, is that now you don't have compatibility issues. Like people always used to meme about this one thing, is that, hey, this software runs on my machine, but it doesn't run on yours. This trouble does not exist with Docker. With Docker, you have like a single runtime that you pertain to. You have a single specific tools. Like even if you are using two different libraries that are not compatible with specific versions, with Docker, you can basically find the right compatibility and you can ship this to any number of developers that you want. I guess this is something that I'm going to cover in the later part of the section, where I will share like how Docker is basically trying to drive a lot of other things in it as well. Like it's not just about creating containers, creating images, and the other parts. Docker is really trying to drive some other ways of collaborating and other things as well. But again, as time permits. So Docker is pretty much like technology agnostic. It does not depend on what language or what framework you're using. All it knows is that you have a single file which defines how an image should be created. This image is a pretty static thing, like it's a read-only thing. And by running this image, you basically get a container. And by this container, you can run your application, you can run the additional tools behind it. And once you're satisfied with it, you can easily deploy this on any sort of managed cloud provider that you want to use. If you're using AWS, you can deploy this on things like ECS or even an EC2 instance. If you're using GCP, you can deploy this on an app runner. Or if you're using Azure, you can try to find some other competitive service that they are pretty much using. In this presentation, I guess I'm just going to stick with a bit of an HTML and some bit of Python and just a little bit of JavaScript maybe. But you can easily use Docker for any tool or technology as long as you have a package manager available with you that allows you to install tools from the internet. It's that easy, to be honest. Um, so one thing that I really wanted to mention before I jump onto the hands-on part is the difference between containers and images. So you might have been like hearing these terms from me like almost every now and you might be cursing me in your mind that, hey, this guy talks too much about images and containers, but he has not yet mentioned about what's the exact difference between the two. So just wanted to underline this one thing. Containers are a way so that you can ship your entire application, and this application is not just your code. Like for example, how many of you have used Node.js before, or maybe just written like a backend REST API or something like that? I guess most of you should have, I pre-assume. So when you're actually shipping your code, it's not just your code. It's not just like a single index.js file or an app.py file or something like that. You not just ship your code, but you also ship the runtime that your code is running on. Now, this runtime can be Node.js, it can be Ruby, it can be Python, it can be anything else. Now, it's not just a runtime as well. It's about the other dependencies like the libraries or the frameworks or the tools that you're using. It's about some other supplementary tools that your application pretty much depends on. For example, if you're building like a backend REST API that connects to a database, like let's say like a MySQL database, you obviously have to like ship like a MySQL database inside your container. Maybe you have to spin this up as another container, and you have to install the tools and the technologies required for your code to connect to that database. So all in all, it's not just your code that you're shipping. You are shipping an entire package that not just contains your code, but also contains your dependencies, your libraries, your frameworks, whatever you're using, and also the runtime and the other tools required for your code to run in a standalone fashion. In a standalone fashion, I mean that if you're putting your code somewhere, like either on your local machine or maybe some cloud provider or somewhere else, it does not require you to actually go over there and install some more tools for it to run properly. I guess this is what most of you should be doing, because I remember my own student experience. I used to share my code to someone and they used to share like, hey, I'm not able to install this whole Flask library. What exactly that is? And I had to go to that other person or tell the other person that, hey, you have to do pip install Flask, and this will install all the required libraries and all the required dependencies for you. This should not happen. In a Docker container, your code basically exists with whatever it needs to basically run in an isolated way. And when you're actually running this code, this is exactly what we call as a container. One important difference that you need to remark in yourself is that there is a Docker image and there is a Docker container. What an image is that it's basically like a blueprint. It's like a basis of a container. It's basically a definition. If you remember, like I was basically showing you all of these images over here. All of these images are just blueprint. Like if I just go to Python, I just click over here and I see this whole Docker pull Python. I will be doing that in a hands-on a bit later. What I'm really doing over here is that I'm pulling the Python image on my local machine, but that's just the image. That's just the blueprint. It is not running. It is not available yet, and I cannot basically do anything with this particular image. But when I actually run this image, what the image does is like it instructs Docker that, hey, we need these, and these things. Can you please create like an isolated environment for me where these things are available so that I can run in an isolated manner? And once it starts running, this is where things start getting a bit interesting. Like this is where you can start interacting with the running container on your machine or whatever machine you're running it on. And you can basically start extending it so that it can actually run your application as well. This is what we will be like talking about in the Docker file part. But I guess this should basically give you like a pretty rudimentary idea. And as I said before, Docker images are read only. It has got no state because it's not even running. And no matter what things you do, it will never change. It's just static. It just remains over there. When you basically create a container out of it, This is when the container basically gets a state. This is when you can start manipulating it. And this is where you can start doing like more wacky things with it. This is where you actually start leveraging the full potential behind the whole Docker as a tool set. So this was my lecture, I hope. And I guess this should give us enough impetus to maybe start with the hands-on. But with that said, I guess maybe we can take up like a bit of questions within a couple of seconds or so. And I guess like after the questions are done, then maybe we can jump straight up into the hands-on part. So if you have any questions, please put that on the Slido. Otherwise, please put that on the Google Meet chat. I'm happy to do like Q&A either on these parts. And just to mention, like what this one thing, if you are more interested about like the various facets of the whole Docker project and how it exactly came to be, maybe just go and have a look at this particular talk. It's by the maintainers of Moby, and Moby is now the open source core of Docker itself. So Docker was initially written in Python. It was open sourced, but then it basically failed to keep up with the latest advancements. So what the Docker company, like Docker is not just a tool, it's also a company. And what they did is like they basically spinned out a separate Moby project, and this Moby project gets contributions from a lot of companies across the world. So these two are the maintainers of Moby, who also work with Docker. And they are basically like sharing like how this whole project came out to be, what are the new advancements, what are the new features and things like that. So go and check out that talk if you're really interested in the whole aspect of the Docker as a technology. By the way, I was basically listening to them in person. In fact, my talk, like I basically talked at DockerCon last year. So my talk was just after this talk itself. So I just remember like this session, like almost on the back of my palm. Shaikin, I guess I will be covering that just after the Q&A is over. So if you have got any questions, please, folks, like put that on the chat, or maybe just yeah, put that on the Slido Q&A. I guess I'll just open the Q&A and check it out right now. Okay, I don't see any questions, folks. I guess hope if there are no questions, I hope everyone is clear. Can I just get a quick thumbs up? Can I also get a quick thumbs up if I'm just following up pretty right? Like, am I having any troubles or something like that in the pace or things like that? Okay, no. Awesome then. So I guess I should not really like stress too much. Okay, we do have one question. So Ayush is asking like, how is Docker different from the virtual environment we create in Python projects? Pretty good question. Virtual environments in Python are just limited to dependencies. They're not limited to runtime. They're not limited to code or anything like that. If you're creating like a virtual environment in Python, all that you're specifying is that, hey, I have this unique Python interpreter over here. Just install this particular version of the dependencies that I want. And the Python interpreter that you have used to create the virtual environment, it will just install those packages, but in your current directory. So it is not isolated at all. It is not like living inside a namespace or something of that sort. It is just setting up the specific dependencies for you of the specific versions so that it does not pollute your system-wide dependencies. For example, if I'm running a package like, let's say, XYZ, and it is using version 1.0, but I am working on a project that requires version 1.2, and I simply don't want to crash any of my other code that is depending on version 1.0, what I will do is that I'll create a virtual environment and I'll just specify the version 1.2 over there, and I can install the packages of that specific version, and it won't interfere with my system version at all. So 1.0 and 1.2 can coexist with each other quite nicely, albeit they would be living in different directories altogether. What Docker does is like it is not just limited to the dependencies that you install, it is also dependent on the runtime that you install. So for example, if your system is using, let's say, Python 3.12, you can spin up another Docker container that uses Python 3.10. This is like you can do this on your own local machine. Like this requires tools like PyEnv and all. But using Docker, you basically have a nice way of abstracting those details in an isolated way. I hope that basically answers your question. Cool. Then, so I guess if there are no further questions, then I can go ahead, maybe with the other parts of the talk today. So maybe I should stop sharing my screen for a bit, and maybe I should like maybe share my whole screen. So give me a second over here. Yeah, cool then. A quick raise of hand if my screen is visible. Okay, awesome. So just to let all of you know, I'm using a very age-old Macintosh that I purchased back in 2021. So yeah, I guess things might break here and there, but my main machine has crashed for some reason, and I simply can't do this session on this particular MacBook. So yes, let's do a bit of hands-on. So okay, yeah, I guess I need to be present over here. Cool then. So as I mentioned before, one of the main reasons why Docker got so popular was because Docker basically ships with a pretty user-friendly client. And the client in question is the Docker command line interface. Now, this command line interface does a lot of things for you. It basically allows you to pull the images.
বেরোতেও পারছি না ধর।
Yeah, thank you. So one of the things that Docker client does is like it allows you to have like a multitude of options that allows you to like pull images from the Docker Hub. So Docker Hub in question is this particular platform that I have already shared you before. It allows you to like create containers. It allows you to load containers. It allows you to like do a lot of other things that would otherwise have been like a lot trouble if the Docker CLI would not have even existed. So Docker CLI is basically our premier way of like managing images and containers on our local machine. Now, Docker CLI happens to be like a pretty widespread tool. I guess the terminal should be visible enough. Uh, and what I can do is like I can just type in Docker, and this is basically where the command line interface basically gets started up. Now you might be able to notice that the most common commands over here includes like run, exec, build, pull, push. Now all of this basically allows you to handle different aspects of your Docker project, and this is like a very easy way of getting started with Docker without handling like a lot of shenanigans. Now, of course, Docker has some other clients as well. I guess one of the other popular clients is the Docker desktop. This is pretty much like a graphical user interface. And even though I won't call this like a direct replacement of the Docker CLI, it still provides like a lot of different ways where you can simplify your day-to-day development processes with the Docker. So for example, if you have the Docker images, like I guess I have a few images here and there, you can basically go inside the images. You can see like what's exactly present over there. You can check out some of the other details that would take like a bit of commands for you to run on your terminal to get to that information. On top of this, you can also manage your containers on Docker. So like over here, I created like a bunch of containers here and there. Some of them are like pretty age old. Some of them were created like years ago. But what I can do is like I can go to these containers. I can check out like what exactly happened with them, their container logs and things like that. But I guess like I won't get into that trouble for now. Guess I had seen a question or someone, maybe. Okay, yeah, I'm going on to that. So these are the commands over here. If you have not installed Docker before, just go on Google, search for Docker installation, and you can find like how you can install Docker. If you're using like a Linux-based machine, you can use any of the traditional package managers like apt or yum to basically install Docker on your machine. If you're using Windows or Macintosh, I guess you have to basically like install the Docker desktop, and this Docker desktop will also install the Docker CLI that allows you to do everything from your command line itself. Uh, you might also be able to notice is that there are a bunch of some new commands, like there is builder, there is buildx, there is compose, there is sbomb, and I guess like these are some of the new things that Docker has been working on, but I'll definitely try to cover that maybe at the end of the session. So if you want to get started with Docker, like just go ahead, install it. And once it is installed, you can just enter like Docker info. And this is going to give you like a pretty nice overview of your Docker setup itself. I was using like a very age-old version of Docker on my machine, and I just upgraded to the latest version just today itself for this particular session. So I just hope that nothing basically breaks out. So if you want to get hands-on with Docker, the very easy way of doing that is the Docker CLI. And if you want to get started with actually running your first image, the best part is that the folks at Docker, they have created this hello world image for us. And what we can do is like we can run this image on our local machine. So how to do that? Let's go ahead and see that. So what I can do is that I can mention the Docker command line, like basically the entire binary over here. And I can just mention Docker run hello world. And as soon as you will run this, you will notice is that it prints like a simple hello world message. It says like hello from Docker. this message shows that your installation appears to be working correctly, and Docker took the following steps. So like every time you basically say like Docker run this particular image or Docker do this, what it does is like this whole Docker client, in this case a Docker command line interface, it will connect with our Docker daemon. Like Docker daemon is basically part of the Docker engine, and this is basically what enables you to run, like basically what enables you to create and run containers on your local machine. As soon as you say Docker run hello world, I guess maybe I should just delete this image. Yeah. Please don't fret if you don't understand these commands, but I just wanted to show you how this works. So when I'm running Docker run hello world, and you can just pre-assume that I'm running this for the first time because this is what you will see when you run it on your own machine. You will see that it says that it is unable to find the image hello world locally. It means that every time you run an image, what Docker will do is like it will go to the Docker hub, it will find that particular image over there, and it will pull that image. Basically, it will download that image on your local machine that would allow you to run that image as a container. If I actually go to my Docker hub and basically search for hello world, yeah, this is where the hello world is. So this is the very basic example of making sure that everything is working on your local machine. So you can see like it has already been pulled like almost a billion times because almost everyone uses this as a way of testing that everything simply works. So what Docker did is like it basically pulled this image. It created a new container out of it. So if I actually go to Docker PS, okay, the container does not exist now. But what it is actually doing is like it creates a container out of it where it runs an executable, and this executable is now printed on your command line interface. So whatever message that we got from the executable, it is basically printed over here. And this basically gives you a quick validation that, hey, everything is working fine. But maybe we can take a look at a more ambitious example. Let's see. So what I can do is that I can go ahead, I can say like Docker run, and I'm going to mention like -it. I'm going to mention like what it's all about. And I can mention CentOS bash. How many of you know about CentOS, by the way? Just a quick raise of hand, maybe. Yeah, I guess some of you. So CentOS is like another open source operating system. And what I'm basically asking the Docker to do here is that, hey, I have this one CentOS image. If you want to validate that, you can go to the Docker hub. And you can try to find it over here. So you can see like CentOS is right over here. It is deprecated. So it means that it is not recommended for you to basically continue using this image because it is not supported, not maintained. But again, we are just using this as an example. So what I'm basically saying to it is like, hey, I have this whole CentOS image. Can you please pull that image for me? Can you please download that image for me? Maybe run that image and maybe open up a terminal for me over there so that I can start interacting with the whole container. So as you can see, what Docker did is like it basically downloaded this image. Like one of the downloads in this billion downloads must be one or two from me as well. And what it does is like it basically pulls the image, it starts the container, and now this container is basically opening up a pseudo terminal for me. This whole IT basically allows me to open a pseudo terminal where I can start interacting with this container itself. So what I can do is like I can mention yum, which is one of the package managers that CentOS uses, and I can install my dependencies. I can create my application. I can do like a bunch of things over here, whatever I want to do. This whole thing is pretty much running in an isolated setup on my machine. Just imagine running a complete operating system. Again, like it's just a container, but again, it has a lot of things stripped down. But just imagine like running a complete operating system that is self-contained inside a Docker container. This is all what Docker basically enables you to do. If I actually go a bit ahead, maybe I should split it horizontally. No, just give me a second. Yeah, maybe I should split it out. Yeah. So what I can do is that I can just go over on the other side and I can just enter Docker PS. So just to give you like an idea what PS is all about. So let me just go at the top. So Docker PS basically allows you to list all the containers. So this is one of the tips and tricks that I mentioned with almost every developer tool is that anytime you're confused, just enter the name of the tool on your terminal, mention the help command, and this will give you like a pretty nice manual about what you exactly need to do. So in this case, I wanted to run like Docker PS, but I obviously want to know what Docker PS is all about. So Docker PS basically allows you to list all the containers on your machine that is running on your machine. So in this case, what I can do is that I can mention Docker PS. And this is going to mention that, hey, I have this one particular container that is running on my machine. It's using the CentOS image. It has the bash command, which basically means that I'm asking it to open up a pseudo terminal on the particular container. And no ports has been assigned to it yet. And it also has like a pretty interesting name, Quirky Carver. Docker basically assigns them randomly based on a dictionary of words it has. But here over, Docker is pretty much showing us like how it is running the containers and what containers are pretty much running on your machine. If I actually go back, you can also like list the images that is running on your machine using this particular command. So I can go ahead, I can say Docker images, and when I actually execute it, you can basically get to see that, hey, these are all the images that is present on my machine. So some of the images I basically created like a few hours ago just for this particular demo. Some of these images have been here for maybe ages. Like one of the images that I created, which is REST API GCP and Flit example, it is almost 6 gigs in size, and I created this almost like maybe year and a half ago. So basically, you can get to see that using the Docker command line interface, which acts as a standard client, you can pull the images, which basically means that you're downloading them. You can create the containers, you can run the containers, and you can pretty much interact with the containers in whatever way you want and whatever way the container basically allows you to do so. So this is basically the power of Docker. Now you can have like an entire setup working on your machine without you having to install any myriad number of tools or setup on your machine at all. So as I mentioned before, Docker is pretty much like relying upon Docker Hub. So Docker Hub, as I mentioned, is like a central place for all of you to store your images and basically make sure that it can be globally distributed, it can be globally served to the entire Docker community. So if you actually go ahead and click on the official images, you will see like Docker has 177 official images. Like these 177 tools are the most popular tools out there, and Docker is basically making these tools available as a Docker image that you can download, you can run on your machine as a container, and you can start using these in your development and in your production workflows. One of the tools that you might mention over here is, of course, something that my company works on. It's called as Local Stack. And you will, of course, see like it has got over 100 million plus pulls, which means that it has been pulled, which means it has been downloaded almost 100 million times. So this is all how Docker operates. It has like a huge community of folks that is building out these images. Even I have contributed like a few basic images over here, like static site or Golang Docker template or Flit example slim. And these images basically allow the entire community to use containers as a way of advancing their application workflows. So either they use it for local development and testing, or they use it for deploying their application on production. The use cases with Docker are simply endless. Now, if you want to like get a bit more creative, there is another example over here. So what you can do is that I can just basically close this out maybe for now. Okay, yeah, here it is. And what I can do is like I can just exit out of it, and I can just enter this command. So every time like I was actually like saying Docker run, I like what Docker basically used to do is like it was pulling the images. Maybe I should just uh, delete this image from my machine first so that the whole process is more natural. Yeah, here we go. So every time what I was doing is like I was mentioning like Docker run this particular image, and Docker used to like download that image in the background and used to run that for you so that it would give you like a pretty quick start. But what if you wanted to like actually pull the image? So in this case, Docker has a pretty interesting CLI command, which is Docker pull. And if you actually see the help manual, you can see like what it basically means is that you can download an image from a registry. Again, this registry is not Docker Hub itself. You can even use the registries, like even you can even use the other container registry. So Docker Hub is not the only registry that you have got over here. There is a GitHub container registry. There is like JFrog registry. Like there are multiple other registries that other companies basically host. And it again depends company to company. I guess most of the common people like us, we generally prefer to use the Docker Hub itself because it has such a great community. It has great such a like huge cluster of images lying around over here. But what if you're working in a particular enterprise setup where just storing your image is not the only requirement. You also have to secure your image. You have to also find out different security vulnerabilities. You also need to make sure that this image is not exposed to any other people over there. So in that case, you might start using some other container registries. Like there is a pretty popular one which is called the ECR, Elastic Container Registry by AWS. And what it does is it basically does the same job as Docker Hub. It contains registries, sorry, it contains containers, basically the images for them, and it basically hosts them so that it can be easily accessed all over the organization. But again, we can discuss about that like a bit later. So in this case, what I did is like, maybe I should just delete it. So in this case, what I can do is that I can pull this image. And what I'm doing over here is that I'm mentioning this pretty interesting thing. I'm mentioning the username over here, which is pretty much like the namespace of the repository through which I wanna like pull the image. And then I actually mention the main image name. You will find like one interesting part over here is that, well, I was like pulling images like, let's say Ubuntu. So in this case, while I'm pulling like image like Ubuntu or CentOS or any other things like MongoDB or something like that, I do not need to mention the username over here. But in this particular case, I need to mention it. This actually pretty much depends on how popular or how compatible your software is. If your software is like as famous as Ubuntu, for example, you won't be like contained inside a particular namespace. But if you are like something like, let's say, maybe, no, this was a bad example. Maybe something like Harsh Casper Golang Docker template. So Harsh Casper is my username. And if you wanted to download this particular Docker image, you have to basically mention my username followed by a slash. And then you have to actually mention the repository name so that it can actually start pulling the image on your local machine. So this is one of the things that you basically need to remember. So what I did is like I basically pulled this image, which is Docker Whalesay. And you can see like even my Ubuntu image was pulled. And once it is done, I can just run this particular image as a container. And even better, I can mention my username over here. So my username is Harsh Casper. And you can see that what it basically did is like it printed the Docker Mobby. I guess it's a whale or maybe it's a dolphin. I'm not sure about that. But it basically prints the whole like animal symbol for the project and also the username that I basically passed over to the particular running container. So this is exactly like how Docker enables you to create images, download these images, and also run these images as particular containers. Now, this was like pretty much like a very basic show of hands. This is how Docker basically works. This is how you can basically get to use it, so and so. But let us now go ahead with it. Let us now try to explore like more complex use cases. Maybe just like I can show you like how you can basically run an entire application on your local machine with the help of Docker. So in this case, as I mentioned, I have this Docker Hub. I have an account of Docker Hub. And within this account, I have this whole namespace where all of my repositories are contained. So if I just go to the repositories, you can see that I have got different repositories like Harsh Casper static site, Harsh Casper Golang Docker template, Harsh Casper flint.example.slim. So if you want to search for particular Docker images based upon a particular username or based upon a particular namespace, you can go to your terminal and maybe you can just do like a Docker search, Harsh Casper. And this is going to show you all of the repositories that a particular user has. So as you can see, like I just searched for my particular username over here. And in this case, it basically printed out all the different images that I created that I pushed to the Docker Hub. And these are basically now visible right over here. So one of the interesting ones that I wanted to show you was this static site. So just to open my Visual Studio Code, I have this static site like project, which I have like packaged as a Docker image. And I will be running this Docker image as a Docker container as a way to show you like how you can like basically run Docker containers on your local machine. And all this application has is a very simple HTML file. Like it's a very simple HTML file that basically says like, hello Docker, that is it. So let us go ahead and let us maybe just run this particular command over here. So what I'm going to do is like I can just say like Docker run Harsh Casper static site. And this will basically start my image like as a container over here. So just start it up over here. And this is it. what I can do is like I can just go to my tab, and you can see like what I was expecting is that like if I actually go back to my Docker setup, and if I actually show you my Docker file again, just pre-assume that you know about Docker file a bit. But what I have basically instructed my Docker file with is that, hey, I have this one single HTML file. Can you please run this particular HTML file using this nginx image? If you don't know what nginx is, then just go on Google, search that a bit. But it's basically like a reverse proxy that allows you to serve your content over the internet. So I'm basically using this nginx image that I pulled from the Docker Hub itself. And I'm basically instructing that nginx image that, hey, I have this one particular index.html file. So please just help me get started with that. And I'm also exposing this on the port 80. But if I actually go to my local host, it's simply not running. Whatever I mentioned to it, like localhost 80 or something like that, it simply doesn't run. The main reason behind this is like, let me just uh, find the Docker PS. Let me just kill it. So if you want to kill like any particular running container, all you can do is like Docker RM. I guess there should be like a better way of doing that. There should be like Docker stop. Basically, it allows you to stop containers, but I just prefer to kill them out, basically remove them out, flush them out. So in this case, let me just go back to my previous command. So I'm mentioning like I want to run this particular image that is already present on my local machine. So the name of the image is Harsh Casper / static site. But the problem is that I cannot like access my particular running container. And the reason for this is very simple. My container is running in an isolated namespace. It's running in an isolated environment. And the port that it is exposed to is this particular port 80. But the main problem over here is that I'm not exposing the same port, or I'm basically not mapping the same port back to my local machine. So as you see, like just go back to the basics. The reason I talked too much about the basics was because of these fundamental things. So if you go back to the basics, you might remember that Docker containers basically run inside isolated namespaces. But these isolated namespaces have no way of talking to the host system. The host system in this case is my OS X operating system. So to make sure that we can expose these running services or these ports back to my host system, I have to start adding some additional command line arguments. The additional command line arguments in this case is -p. And over here, I can mention like 80 colon 80. And what this basically means is that my particular static site that is being served by the nginx reverse proxy, it has been exposed on port 80 on my inside my Docker container. I need to expose the same port back on my host machine, and I need to create like a host mapping between these two things. So I can just press enter. And if I actually go back to my browser, you can see like I have the hello Docker running right over here. I hope most of you might have understood the basic gist of it. Can I just get a quick raise of hand if most of you were able to get the whole part, but what I'm doing? Or maybe just a thumbs up on the emoji side. Yeah. Cool then. So this is exactly like what's happening. The best part about Docker is that it is basically exposing all the logs. Now, logs is one of the most fundamental concepts in the cloud native and the DevOps landscape. Basically, the devil is in the logs. So with the Docker, your application is just not running in an isolated namespace. Using this Docker client, you can also access the logs. You can basically get to see what is happening with your application. So all of this right now is pretty much printed on your terminal. I guess there has been an error about serving like particular content, but I guess the whole application setup is running pretty much fine. If I go back to my Docker desktop and maybe just go to my containers, I can just find the containers that is running right now. How do I do that? Yeah. And you can actually go ahead, click on that, and you can basically go get to see all the logs that my application is spitting out. So if something is going wrong, or if you are debugging a live application, basically these logs are the best way for you to figure out what's exactly going wrong. Again, none of this is running on your local machine. Like it's like Docker container is running on your local machine, but it's not on your host system. It's running inside an isolated namespace. And the Docker CLI or the Docker desktop are pretty much the ways for you to basically interact with it and get to see how it is working out. You can also see that it has its own file system right over here, which is very, very specific. It's not dependent on what you have on your local machine. You can even go inside the container and you can basically start interacting with it. You can start like running various commands over here, and you can start working around with it. You can get to see some other parts, like you can basically inspect the whole container over here. And what you basically see over here is the whole runtime spec that is basically being spread out. So using this, you can pretty much understand what's exactly happening. And many a time, we basically go ahead and see these kind of information to figure out like some particular thing that we have simply missed out because we are just debugging something. We are not able to figure out something. And this is one of the most important pieces of information that we need to check every time we are working on something. So this is where things basically get started for you. The best part is that this is not just limited on my machine. The whole static site repository is pretty much on the Docker Hub registry. All that you need to do is that go ahead, maybe just say like Docker pull Harsh Casper slash statics underscore site, and you can just run this command. Run this particular image as a container and basically mention this particular port, and you will also get to see this particular static site running on your local machine that is being served using Nginx, and we're basically self-containing all of that inside Alpine Linux. So this was about it. If you actually go back to the iTerm, maybe I should just and maybe just split the pane once again. Yeah. So if you actually go ahead and say like Docker PS, you can get to see that the container is pretty much like running right over here. Every container is associated with a unique container ID. And you can also get to see like it has got like a unique name, which is Vibrant Courage or something like that. Using the Docker CLI, you can get to do like a few more things. You can also like rename this particular container over here for something that is to your liking. For example, I can say like Docker rename this particular container ID. I can pass it to the particular command, and I can maybe mention this as Hoogly. And if I actually do that, and if I just do Docker PS once again, you will get to see that the container ID has not changed, but now the name of the Docker container is pretty much standardized to Hoogly, just as an example. You can also like check out the logs. Like for example, you want to see the logs on some other terminal. So in that case, you can mention like Docker logs Hoogly, and this will basically spit out all of the logs for you right over here. Again, with the Docker CLI, you can get to do like a lot of other things. You can also like check out the different important stats for your running container. And you can see like the container ID, the CPU percentage, the memory usage, the net IO, the block IO, the PIDs, all of these information that is very, very crucial for you to start debugging your container itself. So yeah, I guess all that you can do is like just go over the Docker documentation. I guess it should be, yeah. So if you actually go to the Docker desktop, this should directly open up something for you. I'm not sure if it is opening something. Oh, okay. How do I run a container? Yeah. Yeah. Yeah, here is the doc. So the best way to learn about Docker is, of course, the documentation. So go ahead to the docs. You will find the Docker concepts over here, and you will also get some pretty quick getting started guide that I'm already covering over here. So this is possibly for your own future use cases. If you want to go through that, I can maybe drop this on my own. I can drop this on the Google Meet chat itself. So let's move ahead and figure out some other things. So you might be noticing that I have been like running a few commands like Docker RM or Docker RMI, things like that. So what does it exactly mean? So as you might have seen, I have like a bunch of containers. Like I had a bunch of containers running on my local machine. What if all of the containers were running almost at the same time? This would be like a big trouble because, again, the Docker containers have a pretty lightweight footprint. It's like very easy to package, very lightweight. It's consuming very less memory as compared to the virtual machine, but still it consumes memory. It takes a bit of your space. And you might be able to notice is that some of these containers over here are pretty massive, like 6 gigs, 7 gigs, or something like that. There is actually like a pretty famous extension. I'm not sure where should I find it, but yeah, it was an official extension. Yeah, there it is. So it's called as the resource usage extension. So basically, Docker extensions is an additional method for you to install software directly onto your Docker desktop. Now, this is a feature that should not be available if you're just installing Docker CLI itself. You have to install Docker desktop, especially like if you're learning or like just experimenting with things. So in this resource usage, what Docker can do is like it can basically read all of the containers, like all of the images that is present on my machine, and also give me like a quick estimate of how much space is being occupied by them. And like I guess it is pretty much liberal on this side because I'm not running like a lot of things, but on my main MacBook, like this was huge, and every week or so I have to like clean all of the running containers so that I can basically start afresh. So all of these commands that you see over here is basically a way for you to clean up. It basically allows you to stop the Docker containers, remove them out, basically just remove any traces from your machine so that you can save some memory, you can save some space, and you can basically get started with them once when you need it. So in this case, my container is already running. It's called as Hoogly. I guess there is a separate container over here. So let me just kill this. So I can mention like docker kill. And what it will do is like it will just kill the container. That is it. It will just remove the traces of it. If I go back to my containers tab and just ask it to show me the running containers, you will get to see that the additional container that I spinned up because I clicked on the stupid button does not exist yet. If I go back to my terminal, I can do the same thing with this. I can say like docker kill. I can press enter. And you can see like that it's saying that it cannot kill the container. And there is a good reason for this. The reason behind this is that the container that you're trying to kill is already running. So Docker has this whole safety mechanism that basically tells you that, hey, if you have a particular container running, maybe it is better for you to first stop the container and then maybe try to kill this. Because if you're running this application on a production setup, and like let us say that you try to kill this out, this would mean an instant death for that application, and maybe this can create like a huge problem. So in this case, what I can do is that I can say like docker stop, and this is gonna stop my application almost at the instant. If I go back to my other terminal, you can see like it has received the kill switch, and basically my like container would be spinned down in a few time. I can now go ahead, I can say like docker kill, and it can say like my container is not running any longer. So if I just do like a docker ps once again, you can see that there is this whole name over here, but I can say like docker kill once more, and I can just say like -f. Okay, maybe this is not working. I can say docker rm, which is another command for you to like remove your containers. And this basically like is the death end for your particular container over here. So yeah, with kill, you can basically kill your container, you can stop it, you can start it, you can pause it, like you can do n number of things. And with the docker rm, you can basically remove your container. That is the entire functionality. Even better, if you want to not just remove the container, but also remove the entire image, you can just enter docker rmi. So rmi for images, rm for container. That is the whole distinction that you should remember. So I can say like docker rmi Harsh Casper static site. But for some reason, it is still like persisting somewhere here and there. So now I can permanently delete this by enforcing the force flag, which is not very ideal, but again, works pretty well. And in this case, you can see like no containers are running. And if you check for the Docker images, you can see like there is no Harsh Casper /quotes. I guess there is one of them, but yeah, maybe I should do it once again. I'm not sure. Let's see. Yeah, so if I just do it with a ID, I'm sure that this won't be available now. Yes, it's not available any longer. Okay, so there is another one, but I guess it's of a different ID. So I created like multiple images out of that. So maybe that's the reason it is persisting for so long. So yes, if I do another quotes, okay, there is another one, but yeah, maybe these are some of the other images that I spinned up. But this is the whole distinction. Like with Docker, you can basically pull the images, you can download these images, you can start the containers, you can run these containers, you can also like kill, stop, start, pause, unpause, and you can also like remove them once your particular job is done. Even better if there are like multiple containers running on your machine, like there might be a few instances where there are like 8 to 10 containers running at the same time. The best thing that you can do is that you can just say like docker kill this particular command. I can share you the slides later on so that you can easily reference this, but this basically allows you to kill all the containers. Even better, if you want to remove all the containers, you can basically use this variation of the command. And if you just wanna like get rid of Docker after all, like not the whole installation itself, but the images, the containers, and everything, you can just say like Docker RMI and Docker images dash QA, and this will remove all the images from your local machine. Again, use them with caution because sometimes you might have some ill-intended consequences. So just be wary of that. So yes, as I mentioned before, I guess the whole ports part is something that I already covered it out. But yes, something that's pretty okay. Yeah, maybe I should. This is some other application itself. So do I have any questions up till now, or is everything clear? Can I just get a quick thumbs up if everything is clear? Okay. So it seems like a lot of people are still persisting. Is the Josh still high, or like is the whole length of the session dampening you down? Okay, I guess it is still high. Awesome then. Cool. So yes, I had like another application that I wanted to show you because I wanted to cover another important concept that people should know before like they actually get started with Docker itself. So as I showed you on, like maybe it's not on my Docker Hub registry. So yeah, maybe it's on just on my local machine. So I had like this another application that I wanted to show you, and this is the quotes application. So in this quotes application, it's a pretty simple Flask app. And what I'm doing over here is that I have a very simplistic Flask application. So I'm basically using Flask to spin out like a REST API. And I have a database of various quotes that people have been saying for ages and ages. So you can see like the quotes are "well done is better than well said" by Benjamin Franklin, or it always seems impossible until it's done by Nelson Mandela. I guess that's the whole gist of learning something like Docker or Kubernetes. So my main intention behind this application is that I just don't want to like show you like a basic HTML file that runs on your browser. I want to show you something more. And in this particular scenario, what I really want to do is that I want to like create this application. I want to set this up and I want to run this as a Docker container. So in this case, I have specified like a Docker file. If this sounds like Greek to you, do not fret out. I guess this is my last part of the session where I will be covering like how you can write your own Docker files, if time permits, of course. But I have this Docker file over here, and I actually should have, let me see. I actually should have this particular Harsh Casper quotes. I guess I was just mindlessly deleting the static site images, but I guess I should be just using this particular image. My bad. So in this case, I have this Harsh Casper quotes image. And what I can do is like I can basically run this image on my local machine, and this will start a web application where I can start accessing all of the different quotes that great people of the history have said before. So I can say the same. I can say like Docker run. And in this case, you will notice a pretty interesting combination of commands. You will notice that I have mentioned -p, which is of course like just mapping my container port to my host port. So in case of my container, the port is exposed on 8000, and I'm mapping this to my like the host port, which is 8000 in this case as well. You will also notice that in this case, I have mentioned the -d as a command. Now, the reason behind using -d is because it allows me to run my container in a detached mode. Now, there are two ways of running your containers. The first way is running like in the explicit mode. Basically, what happens is like if you're running your container in the explicit mode, like let me just quickly show you this with an example. Maybe I should just delete this once. So in this case, what I can do is that I can go back to the previous command and I can just remove this -d. So when I'm running this particular command, you can see like my logs are directly being spitted out like right on my terminal itself. So this is like one way of like running your container where your logs are explicitly visible to you. Let us say that you wanna like interact with other parts of your application. So in that case, it is very much preferred for you to pass on this -d flag, because that basically means that you can run your application in detached mode. So if you're running in like a production environment or something like that, it's always preferred for you to like just create like detached mode for your container so that it can continue running this in its own process and you don't have to simply bother yourself by checking the logs now and then. So this application is now running. So in this case, I can go back to my web browser and I can just see like the whole application right onto my local machine. I can press the refresh quite a bit, and you can see like every time I refresh my application, it basically says some new code that is present inside the database that I have already created before. So the database data is present right over here. So one interesting fact that might be coming to your mind is that what if I can change the codes that are presented? Like, what if instead of these codes, I can have my own code? So, one of the interesting parts that you might have noticed up till now is that every time I am stopping or maybe deleting my container, it basically removes all of the state. Like, as I said before, every time you like hit the kill or every time you just say like docker rm this container ID, just remove this out. What the Docker CLI will do is like it will instruct the Docker daemon that, hey, just remove this entire thing out. We just don't particularly need it. And the whole state is gone. Now, the state is a very important factor because many a time this state contains information that is very much useful for you. For example, this state might contain some data points that is very much like informative for you, or maybe you're just loading a particular database inside a Docker container, which just basically goes away every time you stop your container. So in this case, Docker has a pretty unique way of making sure that your state does not go away every time you delete your container. And the way of doing that is by using volumes. So Docker volumes is a pretty interesting concept, and maybe I guess the best way to show this is just going to the documentation. So with the volumes, what you can do is that you can persist your data and you can basically load your own data inside a Docker container. So with these volumes, what you can do is like you can do like a bunch of things. Like you can do backups. You can basically share the data between multiple different containers. You can store the data on these volumes and because basically share this with cloud providers. You can encrypt them. You can pre-populate your Docker container with some already available data and a bunch of things like that. So in this particular case, you can use volumes to basically create your own database, or you can like keep adding some new codes and the Docker container will simply keep updating that every now and then. So let us actually do that and let us see like how it basically works out. So in this case, what I'm going to do is that basically let me just stop this. Yeah. Okay. I guess this should be visible enough, I hope. And I can just say like docker rm and let me just stop this container right over here. Once this is done, yeah, let me find the things all over again. I had this one, I'm not sure where has it gone. Templates, database, codes. Okay, let me just create it right from the scratch. Maybe, yeah. Okay, I'm in the slides directory for some reason. Yeah. So what I can do is that I can create my own, let me see. Casper, source, yeah. So let me create my own codes.txt. And yeah, I guess this is pretty much similar to what we had over there. Yeah, I hope so. Yeah. And what I can do over here is that I can just mention, let me see what the format is for the codes over here. So this is like, okay, something like this. So this is an awesome session. And this code is shared by Harsh. So yeah, I guess this is good. So once we have created like this whole codes.txt, what I'm going to do is like I can basically load my present directory as a volume inside my Docker container. Let us see how you can do that. So in this case, I have this one command already available. And what it is doing is pretty much simple. It is instructing that, hey, I want to run this particular Docker container, which is Harsh Casper / codes. I have mentioned my present directory as the working directory, and I'm basically mounting this inside the database directory that is inside the Docker container. So if you actually study the Docker file quite a bit, you will understand that there is a database folder right over here. So what it is doing is it's basically mounting the same file, basically the same directory that we have over here onto that particular directory living inside the Docker container. And this will basically act as the particular database for me. So I can just copy this. I can paste this over here. And this will start my container in detached mode. So if everything just working fine, I guess you will get to see that my code is pretty much working. So this is an awesome session. And this code has been saved by me. That's pretty interesting. If you actually go back to the Docker desktop, you will get to see that my Harsh Casper / codes is running over here. And if I actually check the bind mounts, you can see that I'm actually binding my source directory to the destination directory. So in this case, the source directory is this one, basically the directory where my entire slides and my code is living out. and the destination directory is user source app database, and all of this is basically defined inside my single Docker file. Unfortunately, I cannot talk about it much unless and until I come to the Docker file section itself. But this is basically how easily you can mount your directories onto the Docker containers, and this basically enables you to like make changes inside your directories, see how your application reacts to that, and more and more. There are like various use cases that you can use the Docker volumes for. So this is one of the most interesting ideas and one of the most interesting use cases, and one of the areas where you might enter into several troubles while using Docker. So just be aware of that. Go and read the documentation. It contains a wealth of information for you to basically get started with understanding the Docker volumes in a better fashion. There are like a lot of other things that a 2 hour session will simply not do justice to. And with this, I guess we are almost at the end of the session. This is the full and final demo that I wanted to showcase, and it's all about Docker files. So every now and then, I guess you might have seen me like dabbling around with Docker files here and there. And you might be wondering, like, okay, what exactly a Docker file exactly is. Okay, so someone has said like volumes are like pen drives for a Docker content. I guess that's the best analogy that I can come up with. So thank you, Cloud Native Hoogly, for mentioning that. So just coming back to the Docker file. So as I was talking about, you might have seen like in a demos here and there that I have been like mentioning Docker files here and there. And I'm just asking you to be patient because Docker files might be an alien concept for you. But I guess most of you are smart over here and you might have already understood what Docker file is all really about. So not to break any suspense over here, Docker file is just a special text file. It's basically a way to define your images. That is it. Inside your Docker file, you have a bunch of commands, just like how you write commands inside a shell script. And basically, the Docker file takes up those commands. It basically tells that to the Docker daemon, and it basically instructs them about how they should be interpreting those commands and basically build the image right for you. Now, before the age of the Docker files, creating Docker images was such a pain. It was such a pain because I'm just mentioning like a few commands over here that even I won't be running it on my local machine because it's such like an historic use case. But over here, you basically get to see like how complex it would have been for you to create like something like this, like something like a Docker image without actually using a Docker file. So first you have to use a base image. Then inside that base image, you have to get a terminal access. You have to edit your files over there. Then inside those files, you have to use something like a Docker commit. And this commit basically allows you to like use a new version of the image and basically start testing your changes. If you're still curious about what Docker commit is, I guess since most of you might be experienced with Docker, this is one of the most interesting commands that a lot of people don't exactly know about. And all of this is basically done when you actually go inside the container, you make actual code changes over there, and then you make a Docker commit so that the new image can be basically created out. And with the Docker file, of course, you have to basically like again go and push it to the Docker hub, then have to test it. So it's a myriad of complex setup that you have to follow up through to actually make sense of how this thing exactly works. But with the Docker file, everything is really, really complex. It basically automates the way for you to create your image over here. If you're creating a Docker file, all that you need to have is a directory where you can store your Docker file. You can basically write your code. You can basically specify your code or whatever application that you're running. And then you basically need to have like a Docker file. So as I say, like this Docker file is basically a set of instruction. And this instruction is passed by the Docker CLI to the Docker daemon. And the Docker daemon will basically interpret these instructions and will basically make sense about how to like create the image right from the instructions that you have already shared. So you can see like the Docker file has pretty interesting syntax over here. And it basically depends on these few basic like keywords. Like for example, if you're using something like from, it means that you're basically referencing a base image. The base image in this case can be something like Node.js, or it can be something like, maybe I should just search for Node. So it can be something like Node, it can be something like Python, it can be something like Ruby or something like that. And using this base image, you basically get all of the dependencies that it has pre-installed. For example, if I'm using something like a Node base image, it will have things like npm or yarn or any of the JavaScript dependencies that I might want to depend on pre-installed so that I don't have to install it right from the scratch. In addition, you have got a label keyword over here. and this is basically used to add some metadata information. Then you have got copy, which basically allows you to copy the content of your folder to the Docker image that you will be creating. Then you have the expose keyword that basically tells your container that, hey, whenever you're running, make sure that you expose this port while you're running so that the host can basically pick this up. The host in this case is your local machine. So every time you used to see me like doing like Docker run dash p 3000 colon 3000 or 8000 colon 8000, I was basically instructing the Docker CLI that, hey, I already have a process running on the port 8000, so maybe just expose that for me on my host port. Then there is a work directory, which basically like allows me to like run all of these commands like run, cmd, entry point, copy, add. And then I can also mention like things like volume. So I can like create a volume with a mount point, and basically I can just make my local folders act like a pen drive to my Docker container, as the analogy kind of went out. So this is like one of the basic examples for what a Docker file can look like. So over here, I'm just referencing to the same old static site that I personally had. So I had like a simple index.html inside, living inside this whole site directory. And I had a Docker file that basically uses the nginx base image. It copies my site, like it basically copies this whole site directory inside the nginx HTML directory. And this basically like gives the impetus to nginx to like serve my HTML file through this reverse proxy mechanism. And it exposes the whole thing on the port 80. And every time I used to like run this as like Docker run dash p 80 colon 80, it means that my host machine is picking up on the port 80, which already has like a host mapping to the running process in the container. And this basically like allowed me to access my like application running inside my container itself. So I guess the best way to like talk about Docker files is to basically show you how to write one. So in this case, I'm just gonna do that. So maybe let me just first kill this Docker container, which is done. Awesome. So in this case, what I'm gonna show you is like how you can create a Docker file that basically packages up and exposes your Docusaurus application. If you don't know what Docusaurus is, it's gonna be like very, very simple. It's like a static site generator that was built by Facebook, or basically what you call as Meta right now. And it is basically built on top of React. So what I'm gonna do is like I'm gonna create an application using Docusaurus, just a very basic template that they already have provided. And I'm going to create a Docker file that containerizes the application. And then I'm going to create an image out of it and run that as a particular container. So that's what we are basically going to do. Okay, so seems like there is an error. I guess I know what the error is. So let me just fix this quirk on my machine. Yes, so this should be fixed. I guess we just have 15 minutes, so I guess I'll just try to speed run through this whole process. So yeah, this is basically setting up all of the dependencies for me using npm, and you will obviously like see one of the main reasons why Docker is so much popular is because every time like you pull a Docker image, it has got all of these dependencies basically pre-installed for you, so that you don't have to reinstall them right from the scratch. So maybe let us just wait for it and make sure that it is done. And yes, as I said before, this is what like basically a Docker file does. Like every time like you write a Docker file and you have to basically build the image out of it, you can just use the Docker CLI itself, and you can just see it to like, hey, Docker build. And in this case, I'm using this particular -d flag to basically mention the tag, or basically mention the name for my particular Docker image. So in this case, the name is like my new static website. And once the image is built out, then you can basically run this image by exposing the ports and by maybe detaching from the whole process. So I hope like I can get to show it to you. Okay, so my website is set up. That's pretty cool. If I actually go inside my website, can I just get a quick show of hand if everyone is just following up? Maybe yes. Okay, awesome then. Just wanted to get a quick validation. Cool. So this is my website. I guess what I can do is that I can go to my package.json and I can just make a very quick change. So the one change that I wanted to do was this one. I guess for people like who are already familiar with networking, I guess I don't need to explain that. But I'm just like setting this up so that when I actually Dockerize my application and I like run this as a container, I can expose my application outside of my container. That was the main intention about why I basically added that particular flag. So in this case, my Docusaurus application is set up. It's like running pretty much on my local machine, and definitely the main end goal of this whole thing is that I create a Docker file that basically containerizes the whole application. So the way to do it is that I can create a file called as a Docker file on my local machine. So every time you see like you mention the Docker file, the Docker symbol is automatically picked up, which means like we are pretty much ready to get started. So what I can do is that the very first thing that I will be mentioning is what base image do I want to spin my entire image from. So the reason like why I'm getting this whole Intel license, this whole recommendation by the IDE is because I have this whole Docker extension pre-installed. And this comes up with like a lot of interesting like developer experience features that allows me to like use my application or basically like create my Docker files pretty easily. Let me first kill this particular Docker. Yeah, let me first kill this particular port. Okay, then so let's go back to the Docker file. And in this case, what I'm going to mention is that I want to create my Docker image from the node base image itself. So I'm going to mention like node base image as 18. And that is it. So basically like what I'm telling it over here is that, hey, I want to basically pull the node base image from the Docker hub itself. And if you actually click on it, it will basically redirect you to the node official image that is present on the Docker hub itself. In the colon, I'm basically mentioning the particular version of Node.js that I want to use. So in this case, I want to use the Node 18, which is the version that I'm basically most compatible with. Maybe it's just for my own flavor. So once you mention like, okay, I want to set this up on Node 18, the next thing that you can do is that you can start copying files. Like you can basically mention the source and the destination. In this case, the source particularly is that I first want to copy my package.json, like which is a singular file where I have like all of my dependencies. And this I can basically copy to my own like Docker image itself. Okay, I guess I clicked on the wrong button. Just give me a second. Maybe let me just share my whole screen once again. I hope my screen should be visible. Okay, awesome then. So yes, so let me first copy the package.json inside my Docker image. So the best way to do that is to basically mention like, hey, I have this package.json file. For people like who are already familiar with how like JavaScript works, then I guess like it should be pretty easy. But for people who are not, then package.json is basically the singular file which defines all of the dependencies that needs to be installed for creating the whole JavaScript application. So I have mentioned the package.json and I've already copied it to my like directory on the Docker image. Once this is done, what I can do is like I can mention the run command. And through this run command, I can mention like, hey, I want to install all of the dependencies. So npm is a node package manager, or basically maybe it's just a back acronym or something like that. And basically it will read the package.json file, and what it will do is like it will start installing all of the dependencies that is required for my application to run successfully. Once this is done, then what I can do is that I can copy once again. I can copy my like all of the files that is present in my directory back to my file system in the Docker container. And once this is done, I can see like, hey, I want to expose this particular port. So in this case, I'm mentioning like expose 3000 because this is the port where my application would be running. And once this is done, I can just mention this whole cmd command that basically says like, okay, this is how you start my application up. And that is it. That is the entire thing that you basically need with your Docker file to basically start a very simple JavaScript application right on your machine. Once this is done, now this is where you basically create an image out of it. So you can just say like Docker build, and you can mention the tag. And in this case, I'm going to mention my username first because I also want to show you like how you can push this to the Docker Hub registry and like basically use this website. I can say like, hey, this is Docusaurus, because that's the whole framework that we're using. And once you have that, you need to mention this dot, because this basically mentions the current directory where we are in. Every time you build an image, you have to mention the context, basically the directory context where you're building the image. In this context, I'm building it right from the root directory. So that is the reason I'm mentioning this particular dot over here. Once I press enter, what this will start doing is like it will start pulling the node image from the Docker Hub itself. And this is where it will start executing all of the different commands. So first it has copied my package.json file to the current like Docker file system. Now it is running the npm install. Like this is where all of the dependencies are basically installed over here. And this might take like a couple of seconds or maybe even minutes here and there. I'm not exactly sure about that, but that totally depends on my internet speed. Once this is done, this will copy all of the other files and folders that is present inside my website directory into my Docker file system. Then it will expose port 3000, which is basically mentioning to Docker daemon that, hey, this whole process that will be running inside the isolated namespace, it will be exposed on the port 3000. So please just open that. And once it is opened, then we will execute this particular command, which is npm start. And this will basically start up my whole JavaScript application. So this is exactly how write your Docker files. This is exactly how it works. There is no rocket science. There is no like magic behind this. It's basically a very, very easy way for you to get started with building your images, distributing that using a particular container registry, and also collaborating with your fellow team members about how you should basically like create your own images out of it. So for some of the people who might want to be like Docker geeks, there are obvious like mishaps with this Docker file, just to mention you before. For example, I should be just maybe putting them in separate like closed brackets or something like that, and maybe putting up double quotes on them, because this is exactly like how I can fully leverage the extra additional capabilities of like creating like much slimmer images. But again, like we are not talking about how to create slim images or something like that. I'm just trying to give you an example of how to create your own Docker files and create your own Docker images out of it. So I guess this should basically give you a nice idea about how this whole process is done. So just going back, and yes, once like your Docker image is being built up, I guess this will definitely take a bit of time because we have already spent like 2 minutes here and there installing all of the dependencies. But once this is built up, what you can do is like you can tag your Docker image over here. The good thing is like I have already tagged it over here by mentioning my username and the particular name of the repository where I want to push it to. And then you can just say like Docker push, and this will be pushed to the Docker Hub registry itself. But just be aware, you have to first log in. So like all that you need to do is maybe just go over here, just say like Docker login, and this will basically ask for your username and your password, and this will basically set you up to start using the Docker Hub. So there it is. I guess like my image is built up, and you can see like everything is now available. And what you can do now is that you can just see like Docker push or Casper, and you can mention the name of the repository. And as soon as you will do it, okay, I guess I misspelled this a bit. So Docusaurus. So what this will start doing right now is that it will start pushing my image back to the Docker Hub. And just maybe in a few seconds or so, because my image is very, very fat, it's like almost like you can see like the multiple different layers over here and how much data is present in every layer. So it might take a bit of a time, but there are obvious ways where we can make this like much slimmer. For example, in this case, I'm just copying my entire current directory back into my Docker file system, which is obviously wrong because even my node modules are being copied, and these node modules are very, very expensive. Like these are very, very heavy. If I just go to my file system, like maybe if I just see the info, you can already see that I am copying almost how much? Not sure about that. Yeah, I'm almost copying like a 180 plus MB into my Docker image, which is not very ideal. But again, like I just wanted to give you an example, but there are better ways of writing this Docker file right over here. So this will take a few seconds, but once this is done, I can go to my repositories, and I will definitely get to see that there will be another repository over here, which is called as Docusaurus, and this is where like my entire repository would be kind of hosted. So yeah, this was pretty much it. This was all of the things that I wanted to show you for the day. As I said in the beginning, there are obvious things that I'm skipping over in this particular intro. For example, I'm not talking a lot about the networking thing because this is something that you can explore on your own. And this might also go beyond the time limits for this session. I'm also not talking about the Docker Compose, which I guess is something that you would be encountering very, very soon. But at least what I mentioned over here, the basics of Docker, how Docker came out to be, how you can write your own Docker files, and how to use the Docker CLI should give you a pretty strong foundation of getting started with Docker overall. So yes, this was it. This was what I wanted to show you for the day. I guess my image is still not pushed up, But yeah, I guess it is done now. So if I just go ahead, maybe refresh this a bit, I guess, yeah, this image is right over here. So I guess this can be like a good assignment for all of you, is like just go ahead, say like docker pull Harsh Casper slash Docusaurus and try to run this on your machine. There's just one additional thing that you might want to put on your command line argument, and I guess I can leave that on to you to figure out. But yeah, that was pretty much it that I wanted to showcase. Thank you all for being so patient and so persistent in this whole session. And now I'm all up for taking up whatever questions you all might have. Thank you. Yeah. So just as a quick round, maybe what I wanted to ask from all of you before we all close up is just one final question for the day. So please bear with me, go back to the Slido once again, and just join the slido.com and maybe enter this particular code over here. Or if you want, even better, I can maybe share this whole link with you. So maybe you can just enter it once again. So you can also use this as a Q&A. So please join this if you want to ask me some questions. But there is one final thing that I want to ask from all of you, is that what was your overall impression of the session? So based upon your anonymous feedback, please feel free to add whatever rating felt best to you. Again, this is completely anonymous, and whatever feedback you give, I would really, really appreciate it. Cool. So yeah, I guess I will be taking up questions now. So I guess I do see a few questions. So Ayush has already mentioned, like, is there any git ignore similar to for ignoring the node modules? I guess it has already been answered. Yes, there is a docker ignore, and yeah, you can definitely use that. There are additional tools that allow you to basically find out the different issues with your Docker file. So like there are specific, what we can call it, like Docker file linters, I would say. And these Docker file linters can basically statically analyze your Docker file and can basically see like, okay, this is something that is missing out, or this is something that you need to fix. And it can give you like a pretty nice overview of what are the things that you need to figure out before you actually use the Docker file in the real production setup. Like for example, if I use a Docker file that I created before, like just as an example, if I just remove it, you can already say like it has started finding some issues over here. It is saying like, okay, always tag the version of an image explicitly. And it is not just coming out of like issues out of the blue. Basically, like these kind of linting issues are governed by HadroLint, which is one of the tools that is used for linting your Docker files, basically analyzing and trying to figure out like what are the different issues with your Docker file. And they have like these multiple rules that you need to abide by. So anytime you're writing your Docker file, maybe just go ahead with this particular tool and use this as a way of validating that, hey, everything works pretty well on your side. I guess this is a really, really nice mechanism for you to write like picture perfect Docker files at the end. Okay, so coming back to the questions, what is the difference between virtualization and containerization? I guess I already discussed about that a bit before, but just to summarize this a bit, virtualization is all about using a hypervisor where you can basically emulate like multiple different operating system running on the same host machine. On the other hand, containerization is all about running on the same operating system, but running it in isolated namespaces. How Docker basically does this is basically it uses a magical combination of namespaces, chroot, C groups, and more of that stuff, along with some sprinkle of security, networking, and things like that. And it basically provides you a really nice mechanism for containerizing your application and basically using containers to like mimic real world applications. I guess that's what I would answer for now. But if you just want to cover it up once again, I have this whole slide deck available right on the internet, accessible through a very simple website. So all you can do is like basically go over here, click on this, and you will find all of the content that I have shared for this session on this particular website. So just go ahead, whack out, and I guess you will be able to cover up like a few of the doubts you might already have. Yeah. So Trideep is asking like any automation tool or Python libraries to automate the processes in Docker. I guess I am not very sure about this, to be honest, because Docker is all about like actually containerizing stuff. Like it does not allow you like any way of automation at all, unless and until you are using some sort of a managed service provider with this. For example, like let us say that you want to automate like sending you some emails or something like that. So in this case, you can like write a serverless function But you can of course like package that whole serverless application as a Docker container, and you can push that to a managed cloud provider, and that can be run as a cron job. So this is like one of the basic automations that you can do alongside a Docker container. So yeah, those use cases are pretty much popular and quite practical as well. Okay, so someone is asking like Docker and OpenShift the same. That's a pretty interesting question because I worked with the OpenShift team almost 2 years back. So OpenShift is not exactly like a container technology. It's more of a container orchestration tool. So I guess most of you might know about Kubernetes. So OpenShift is more comparable to Kubernetes in the sense it's basically like a managed distribution of Kubernetes that is being maintained by like Red Hat. And this is like basically what allows you to like spin out like multiple containers on the cloud and basically scale your applications. Again, OpenShift does not use Docker under the hood. So I guess a couple of years back there was a very wide controversy about Docker basically resorting to like paid licenses. And due to this, a lot of organizations started to reduce their reliance upon Docker. They started like actually going back to some other tools like Podman or maybe Container Red. So OpenShift, it's owned by Red Hat. So in that case, OpenShift pretty much dropped the support for Docker, and they actually got back with one of the tools that they have built out, which is called as Podman. So if you go to the main website for Podman, you will see like it's the best free and open source container tools, which is obviously not very true, at least in my opinion. But Podman is pretty much like a competitor to Docker. They both use the same OCI specification under the hood, but Podman kind of advertises itself as more of like Kubernetes friendly, while Docker is more towards going into how they can pretty much like revolutionize developer experience and things like that. So yes, OpenShift and Docker are not the same, but of course the foundations are pretty much like hiding in the same way itself. I guess a more comparable comparison would be like about Kubernetes versus OpenShift or Docker Swarm versus OpenShift, because these two tools are like two or three tools are more of like container orchestration tools, I guess. So yeah. Yeah. Any more questions? Let me check maybe if there are more questions. So someone has asked like, can I use JSON instead of YAML for my compose file in Docker? Some people might find it interesting, but yes, you can. But that would be like too complex, because the very basic idea is that YAML is a superset of JSON. So whatever JSON file you will write, it can be like a valid YAML. So you can definitely use like a JSON file with compose, but I guess that would be like quite a complex hotpot that you don't obviously want to deal with. So yeah, just take my advice on this. So if there are no more questions, I guess we can maybe call it a day. So thank you all for your patience. And yeah, if you have any more questions, please hit me up like on LinkedIn. I guess I'm quite moderately active on that particular platform, to be honest. So maybe I can share my LinkedIn profile over here.
Thank
And
you
yes, I
so
guess yeah, they must have a quiz
Thank you
right
so
now.
much, Harsh. And
Yeah.
like it was a great session. And actually, being into the CNCF and this particular cloud native ecosystem, I have haven't heard about Docker. Okay, for
Mhm.
example, this was the first time I actually encountered this thing. So
Yeah.
also and also this linting thing for the Docker files. Learned something new. So
Yeah.
thanks, Harsh, for coming in Cloud Native Hugli and sharing your knowledge. And the
Yeah.
community is really very happy with whatever they have learned from you. And actually, we are looking forward to have you in more such sessions. And yep, thank you so much.
Thank you. My pleasure.
And please do actually provide your feedbacks in my DMs, and if possible over here as well.
Yeah.
Yep. Yep. So we will actually proceed towards a quiz round, quick quiz. And Harsh, it's up to you. You can stay, or you can call it a day. Up to you, man. Thanks for joining, Harsh.
Okay.
So let's move towards quiz now. Uma, over to you.
Yes. So it was a great session. So we guys can go back and flex about our Docker knowledge now to our peeps who have not joined the session. So Nimesh, okay, Sanita is presenting.
I
Everyone,
hope it's
please join.
visible.
Yes, yes, it's visible.
Okay, okay, cool.
So, as you all guys know, we conduct a quiz at the end of every session, and there are swags for the winners. Please join the session. The link is in the chat, I guess. Yes.
Rima, what's the count of the participants in the meeting right now?
38.
38.
Okay, so we can expect at least 30.
Yes. Join fast, guys.
Folks who have actually joined these quiz sessions already know that there's something fruitful at the end of this. So, yeah.
Yeah.
Who is that mayor who docker?
जो भी अतरंगी नाम आएगा, you guys have to, know that it's either Nimesh or someone from our team.
Guys, please अपने real ID से आना. Otherwise, it's very difficult to trace who is it. And at the end, swags तुम्हें नहीं मिलेगा. तो, yeah.
Yes.
I can see some common names as well. Like a great appreciation for them. They are the consistent participants here.
Yep, yep. There are many active ones who attend every session.
अरे मैं भी अटेंड करती हूँ हर सेशन, मुझे तो कुछ नहीं मिलता.
Rita, I could see them in most of the sessions.
Kiran, your question will be answered by Ronit.
Oh,
No,
हर बार निमेश
you have to join on Slido.
Definitely not Nimesh. Nice. I like
so
this.
I think we are touching 2 members. So can we start?
Okay, it's
yeah, it's 30.
Yeah,
30,
let's go.
so we'll be starting. 1, 2, and 3 go. What is Docker? The basic question.
I just want to see ये कौन गलत लिखता है.
Okay. Okay.
29% people.
Which of the following is a feature of Docker? Nice. This is a good number.
I just want to know who are the Windows only support guys.
What is a Docker image?
जिसने सेशन अच्छे से सुना है उसको पता है आंसर.
बिल्कुल. Okay.
You can put it in the pocket.
69%. Which command is used to list all running Docker containers?
ये सबको
मुझे
आना
डॉकर
चाहिए.
डॉकर से email आ रहा है बहुत ज्यादा. भाई ट्रैप था. भाई ट्रैप.
गुमराह करने की कोशिश सफल रही. What command is used to log into a running Docker container?
ये भी लोग बहुत कंफ्यूज है. ये तो एग्जाम का वो हार्डेस्ट ऑप्शन ओनली वाला केस हो गया.
Oh, nice.
PS dash A से all of the like all of the containers are being listed. Anyway, dash A tag is for all. Huh.
Nice. This is nice. 68% correct.
Hmm. Hello, busy guys.
What is minus IT flag stands in total command?
ये
Okay.
तो हर्ष ने बताया था. Guys, क्वेश्चन देख लो पहले.
Don't take hasty decisions in your life, folks.
ये भी ट्रैप था.
ये भी
Top
trap.
3 people will get blueberry cheesecake from our lead.
ये कैसा लालच है किरण?
Hashtag
I
social
love
media.
cheesecakes.
डॉगर कंपोज हमको पढ़ाया नहीं.
डॉकर कंपोज हमको पढ़ाया नहीं. ये बोनस क्वेश्चंस मांग के चल लो.
हाँ exactly.
ये गेस करने के लिए है.
54%.
बहुत लोगों को आता है. चलो ठीक है, डॉकर कंपोज किसी और सेशन में मैं पढ़ा दूंगा, कोई ना.
Which file format is used by Docker Compose to define
ये
services?
इसमें तो कवर हुआ था. ये तो कवर हुआ था लास्ट मोमेंट में. हर्ष ने बताया. Which one is easier to use? चलो दिमाग से.
Wow.
Nice.
YAML, anything that is relevant to cloud native is very easy to handle with YAML. Okay, ये दिमाग के अंदर घुसा दो. Okay.
What? Which of the following is not a common use case for Docker?
बहुत easy है ये वाला तो. सही है.
Okay. What command removes unused Docker images?
It is not covered, so I think people will not.
Let's see.
ये पूरा केस वर्क चल रहा है इधर. ग्राफ एकदम फटाक से फ्लक्चुएट कर रहा है.
Okay. Nice.
लोगों को तुक्का सही लग गया.
Who is this Ami Kiran? I guess this is
हाँ, ये
Nimesh
कौन है?
Kiran. किरण देख लो तुम्हारा नाम यूज हो रहा है विदाउट योर
So ठीक है, at least top of the table तो है.
हाँ एग्जैक्टली.
हाँ, ब्लूबेरी चीज़केक के लिए तो कुछ भी. बस एक क्वेश्चन बचा है.
Last question.
Last question.
Which Docker
Yes.
networking mode is the default option?
वो पूरा केस वर्क है. पूरा केस वर्क है इसमें तो.
Okay, still 32%. Okay.
Leaderboard. अरे
लीडर बोर्ड वो निकालो. ऑफिशियल वाला
फोर्थ
ये
वाले
गाना
को कुछ नहीं मिलेगा क्या?
Okay, wait.
हाँ, किसको नहीं मिलेगा?
फोर्थ वाला
Have the leaderboard.
नहीं, फर्स्ट 2 तो हम लोग कैंसिल कर रहे हैं.
Sancta, click on the settings one. हाँ.
I can actually present the leaderboard. Uh, you want एकदम नीचे.
यही है ना leaderboard.
I think so. But
हाँ यही है.
हाँ ठीक है.
What the timings? Okay, so I
Shaunadev Das again.
will consider this from the third position, right?
ये सेकंड वाला कौन है मुझे पता नहीं है. थर्ड वाले से स्टार्ट करते हैं.
हाँ.
Are you there in the meeting, Viking?
yes.
Okay, congrats, you grabbed.
Congratulations.
Thank you.
ब्लूबेरी चीज केक आपका होता है.
Okay, इसके बाद है सौविक मंडल.
Sovik Mandal.
Is he the first time winner?
Yes, I am the first time.
Okay, you are
Wow.
winner of the second position. Congratulations.
Thank you.
And Shamadev तो टॉप
था
प्लेयर है.
था पहले.
Daily customer.
और इसके बाद है श्रुति. Is it
Yes, sir.
idea?
Yeah, Shruti is there.
Okay, you are the real ID. Okay, congrats. You grabbed the third position.